So now that we know what we mean by left hand sum and right hand sum, let's do it, right? So remember, and I'm gonna sort of shorten what I just said in the at the end of the last video, right? So this is what I generally do when I know I'm going to use left hand and right hand sum, right? I know I'm going to go from t equals 0 to t equals 4, and I'm going to use 4 rectangles, right? This one's kind of very simple, but in order for you to get you want to have rectangles of equal width, kind of like we did in those other videos. And so one of the things you want to do is you always want to be able to find the width of your rectangles. And one easy way to do that is to take your interval, the maximum or the endpoint of your interval, minus the lower endpoint, and divide it by the number of rectangles you're going to have. And then you'll see that you're going to have 1 as your width of your rectangle. And so that's why we know we're going to do 1, 2, 3, and then 4. When I do my left hand sum to give me the total change in your variable here, and I'm going to use my left endpoint, and I'm saying left hand sum LHS. I'm going to use my left endpoint, this endpoint, and that endpoint, and I'll leave that one off. And then my area is going to be given by 1, which is going to be the width of my interval, times this leftmost endpoint, which is 0. So I'm going to say times f of 0, plus the width of this one, which is 1 unit, times this left endpoint, which is 1, plus 1, which is the width, times f of 2, plus 1 times f of 3. Okay. Again, we could write that as 1 times f of 0 plus f of 1 plus f of 2 plus f of 3. And I'm going to use my calculator and my table feature to help me figure that out instead of doing that by hand and or entering it for each one. And I get that my total change for my left hand sum is going to be 1. F of 0 is 75. Got 48 for f of 1, 27 for f of 2, and 12 for f of 3. I multiply those out, add those up, multiply by 1, I get 162. All right, I don't know my units here, but it's not a rate of change. It is some value. Okay, that's my left-hand sum. Now I'm going to calculate my right-hand sum. All right, and it's going to give me the total change, but I'm going to leave off the left-hand sum and use these sums, these t values here. And so my width is still 1 unit long, right? The width, this is from here to here is 1 unit, here to here is 1 unit, here to here is 1 unit. Sorry, 1 unit there, right? And so I'm going to have 1 times, not f of 0 like I did with my left-hand sums, but f of 1. Again, I can write it as a factored form, and I'm going to go ahead and put the values of these things. So f of 1 is 48. F of 2 is 27. F of 3 is 12. F of 4 is 3. Add those up, multiply by 1, I get 100. Sorry, I don't get 100, I get 90. Okay? And so that is what I get when I use my left and my right hand sums. All right. Part B asks us to estimate the total change from t equals 0 to t equals 4 using 8 rectangles by finding left-hand sums and your right-hand sum, right? And so again, I have that situation where I'm going from 0 to 4, but this time I'm using 8 rectangles, right? And so I've got to divide this interval into 8 pieces, 8 equal intervals, so that my width of the rectangle is always the same, right? So I'm going to divide it into 8 equal intervals, right? Okay. For me to do that, I'm going to do 4 minus 0. So my top endpoint minus my bottom endpoint, I'm going to divide it by 8 this time. That gives me a half, right? And so this endpoint here is going to be 1 half. This is 1. This is going to be 3 halves, 2, 5 halves, 3, 7 halves, 4. And you can put 0.5, 1.5, 2.5, 3.5 there if you like. Okay? And so the only difference in using 8 rectangles is that, oh, well now I just have more rectangles, right? But when I do the left-hand sum and the right-hand sums, left-hand sums, I'm going to leave off the rightmost endpoint and use my left-hand sum. And then the right-hand sum, I'm going to leave off my leftmost endpoint and use that one as to create my rectangles, right? And so I'm going to do my left-hand sum first. I like that one. So my left-hand sum that's going to give me my total change is going to be, I'm going to have 0.5 times f of 0 plus f of 0.5 plus f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5, right? And I leave off that 4, okay? Again, your calculator's table feature would really help you get these numbers quickly. And so I've done that in my calculator. I'll show you when we get in class. But I get 0.5 times 75 plus 60.75 plus 48 plus 36.75 plus 27 plus 18.75 plus 12 plus 6.75. Put that in your good old calculator and multiply that by 1/2. You know, do that entire thing. You get 142.5. For our right-hand sums, here we're going to leave off 0 and include all these values and our right endpoint, right? And so I'm going to get 0.5 times f of 0.5 plus f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5 plus f of 4. All right, and you get your good old calculator. Use your table feature so you can quickly find these values. I get 60.75. If you don't have a table feature, just enter these into the function, right? Your function was f of t equals 3 times t minus 5 squared. So put these values in for t in order to get each of these individual values. It takes a while because there are so many values, but that's what you do. I get that, put in my calculator, I get 106.5, okay? And so as you can tell, when we use more rectangles, we are going to get different numbers, right? We're going to actually get different values here. When we did our left-hand sums, we got 162 when we did 4 rectangles, but we got 142.5 when we did 3 rectangles, right? I'm sorry, 8 rectangles. When we did 4 rectangles, my right-hand sum was 90. When I did it with 8 rectangles, I got 106.5. And so my question is, which do you think is the better estimate? Which do you think is the better estimate? And we're going to pick up with this in class. So hopefully I'll see you guys very soon, and we'll pick up here to answer this question and continue with the lecture.